Hello everybody, welcome back to another math video. I'm Mr. Schmidt and today we're going to be talking about volume of prisms and cylinders. Volume is the amount of space enclosed in a three-dimensional object, but a lot of times they're going to talk about volume with something like a pool and how much can that object hold inside of it. With pools, they will frequently describe their size by the capacity, or it'll be 400 gallons. And the question is, how do they know how much can fit inside that pool? Because they're not standing on the edge with gallons of water pouring them in one at a time. There has to be a mathematical way to figure that out. And by the end of today's video, I'm hoping that you're able to figure out what that is. Since it's one of my videos, though, we have to throw in a little pun before we get started. Here we go. Today's video is only going to be covering the volume of prisms and cylinders, so we need to make sure we talk about what those are. Now, this is not the most mathematically correct definition, but this is the one that I share with my students. A prism is a solid three-dimensional geometric figure whose end faces are the same shape, and then all edges must be the same line. So there's a few examples of what that means. A rectangular prism, for example, would have a rectangle as the top and bottom or front and back. The faces have to be identical rectangles. A cube would be a square prism, two identical squares. A triangular prism, this is my favorite candy in the entire world, Toblerone. If you notice, the front and back are identical triangles, but that could be top and bottom depending on how you turn it. Now, a cylinder is not a prism because it has curved edges, but it has an identical circle on the top and bottom. So for volume, it's treated very similar to how a prism is treated. One of the shapes we looked at in the last slide was a Rubik's Cube, which is a square prism or a cube. And we want to figure out, what is the volume of that shape really mean? Okay, and before we talk about the volume, I want you to think about what the front face of that shape would be. Now, front does not actually need to be the front. It just needs to be a shape that is repeated identically in the front or back, top or bottom. So I decided to choose one of the sides, and I went with the white side. Now, I notice here that I have 9 identical squares, which means that this has an area of 9 square units. Square because it's two-dimensional. It's completely flat. If I made that side three-dimensional, like this, now instead of squares, I have 9 cubic units, making it three-dimensional. Now, what's interesting about volume here, I'm going to set my pen down, is that what you can actually do is you think about repeating that front face over and over. Now, I have 18 cubic units. If I do it again, I have 27 cubic units. I'm figuring out the space enclosed in the object, or the space inside the object, which means if I had a 7 by 7 by 7 Rubik's Cube here, massive, right? What I could do is I could think about how many squares are on the front face, which could be any side in this case. It doesn't actually have to be the front, which would be 49, okay, because 7 times 7. And I take that times the three-dimensional measurement, which would make it 7 times 7 times 7, or 343 cubic units for the volume. Most of the time, we're not going to be working with shapes like a Rubik's Cube, which has the same measurements on every side and has squares cut out for us. So we're going to need a few different methods. One of the methods is you can use a volume formula for each shape. For example, this rectangular prism has the volume base times height times depth to get the volume, and we just simply calculate the base length would be 8 3/10 here. The height would be over here, which is 6 centimeters. And the depth of the shape here is 6 as well. And if we multiplied that out, you would get 298 8/10 cubic centimeters because it's three-dimensional. So you can always use the formula to do the calculation. However, if we remember what we talked about in the last slide, that what you're really doing with volume is stacking a shape repeatedly, we just have to decide what we're going to define as the front face or the base of one of our shapes. And we just simply find the area of that. Now, I'm going to choose something a little bit different. A lot of you are probably going to choose this front for that base. I'm going to actually choose this side over here, okay? Because it just has to be a shape that's repeated on both. Well, the area of our base here would actually be 36 square centimeters. It's flat. And then what we're going to be doing is we're stacking this repeatedly in this direction. And we're going to do that 8 3/10 times, which is kind of a weird way to think about it, but we're stacking it in that direction. So we take that times whatever makes this three-dimensional, so the 3D measurement. In this case, it's depth, but that could be height, that could be anything, okay? We take that times 8 3/10 centimeters, and wouldn't you know, when we multiply that out, we get 298 8/10 centimeters. And we're going to show you a video here that you can calculate volume mathematically, but you can also calculate it scientifically. We're going to try to prove that the volume we just found of that rectangular prism is correct. This shape here I filled with water, and we mathematically found its volume to be just under 300 cubic centimeters, which should be the same as just under 300 milliliters. So I have my measuring cup here. I'm going to take the water here and I'm going to fill this up. And it's a little bit hard to tell, but we are just under 300 milliliters, which means that our mathematical calculation of that rectangular prism's volume was correct. Let's do one more example. This time we're going to find the volume of a cylinder, which has a circular face on this case would be the left side and right side, but it also could be a circular face for the top and bottom. Very similar to a prism, but since it has curved edges, it is not actually a prism. However, the process for finding its volume is actually the same. If we use method 1, that would be the base area, and we would take that times the 3D measurement, which in this case will be length, but it could also be height or depth depending on how it's tilted. Now, the problem, though, is that we are dealing with a circle, okay, for our base. So right here or right here will be our face, our front face or our back face. So the area of a circle, though, is radius times pi. And then when we find that answer, we're going to take it times, in this case, we're going to call it length, or we'll go depth here. Okay? Well, radius times pi, the radius of this circle is actually half of 6 4/10. So that would make this 3 2/10 times 3 2/10 times pi. Pi is about 3.14 or 3 14/100, but it's not exact, so it's best if you can use the pi button on your calculator. And then our three-dimensional measurement here is 13. If I type all of this into a calculator, it is not exact because pi is not exactly 3 14/100. So it is going to be about 418 21/100. In this case would be centimeters cubed. Okay. Now, once again, method 1 and method 2 are actually the same because if we notice, radius times pi is the same as that base area. Okay. Now, they also label height. In this case, height is whatever the three-dimensional measurement is. If we tilted this up and stood it, then you would have it be the height. In this case, it's the depth or the length. But either way, you end up getting the same thing, same area, 418 21/100 centimeters cubed. On the next page, here are some volume formulas for prisms and cylinders. Now, once again, remember what you're doing is you're finding the area of the front face or bottom face or whatever you're looking for, and you're taking it times the three-dimensional measurement. So in this case, base times height, this would be a rectangle, finding the area. Triangular prism, you find the area of a triangle, take it times the height. A cube, which is a square prism, you're just finding the area of a square times the three-dimensional measurement. And a cylinder, you find the area of a circle times the measurement. Okay, so this brings us back to the original question that we started with at the very beginning. How would they know how large the pool is? And the answer to that question is because a pool is, in most cases, a rectangular prism. So they would find the volume by figuring out the volume of the equivalent rectangular prism, which would be one of the formulas that we use today, and that would tell them how much water could fill in that pool. As always, if you have any questions, please let me know.